This is Geometry, Unit 1, Lesson 2, Reviewing Linear Equations and Inequalities. Before we get into the heavy stuff with geometry, we have to be able to remember how to do the stuff we learned in algebra. So we are going to do a quick review of how to solve a linear equation and inequalities. So the first thing we're going to look at is the difference between evaluating something and solving something. So we have two problems here. We have evaluate 4x plus 3 for x equals -2, and we have solve 4x plus 3 is equal to 9. All right, when it says to evaluate, evaluate means we know that we have an expression and we have a value to plug into the expression. So if we have 4x plus 3 for x equals -2, what that means is to use substitution. We're going to take -2, plug it in for x, and solve. 4 times -2 plus 3. Now remember your order of operations. 4 times -2 is -8, plus 3 is -5. And we have evaluated that expression. Now an equation is solved. To solve an equation, we have to undo what has been done. We have to use the properties we talked about yesterday. 4x plus 3 is equal to 9 means that we have to undo adding 3 and multiplying by 4. So we do them in reverse order. So instead of adding 3, we subtract 3. Remember, you have to do it on both sides of the equation. That's the addition property. So 4x is going to equal 6, or that's the subtraction property technically, yes. And then you have to divide by 4, and you get x is equal to 3 over 2, or 1.5. Now, this should not be new stuff to you. We've been doing this since forever. So this should not be a new idea. We just want to break you back into the new stuff. Now, when we're solving linear equations and inequalities, we have to be able to understand what's being asked of us. An equation says that two expressions are equal. Okay, that's why it has an equal sign in it. Each part of it is an expression, and those two are equal. An equation is linear when its highest exponent is 1. Notice there's no squares in here, there's no cubes. Every x value, every exponent has an exponent of 1. So this is a linear equation. All right, so what are the steps for solving a linear equation? Well, we have 5/3 x minus 9 is equal to 3/4 times the quantity x plus 10. What do we do first? Well, remember our steps. First step, distribute. We have to distribute through our parentheses. All right, so we 3/4 times x, and then 3/4 times 10, which is equal to 30 over 4. I'm going to leave that reduced for just a second. Okay, now our next step is to get the x's on one side and numbers on the other. However, notice there's lovely fractions here. Do you remember the trick for getting rid of fractions? Yes, you can use your calculator and move the stuff over that, but what if we got rid of the fractions altogether? All right, the rule for getting rid of fractions is multiplying the entire equation by its least common denominator. So if we look at our denominators here, we have a 3, a 1, a 4, and a 4. What's the least common denominator? Well, it's 12. So if we take each expression, I'll put this one here, multiply this side by 12, and also multiply this side by 12. Look what happens. 12 times 5/3 x, the 3 cancels the 12, multiply what's left, you get 20x. Don't believe me? Put it in the calculator and see. All right, now the 1 doesn't cancel the 12, but 12 times -9 is minus 108. The other side of the expression, also multiply by 12. 3/4 times 12. 4 cancels the 12, giving you a 3. 3 times 3 is 9x. And 4 goes into 12. 3 times 30 times 3 is 90. Look at that, no more fractions. Once you do that, it's just solving the equation as you normally do. Subtract the 9x. You get 11x minus 108 is equal to 90. Add 108. 11x is equal to 198. Divide by 11. And we end up with x is equal to 18. So the trick of multiplying by the LCD can save you a lot of time, especially when you're doing fractions. All you have to remember is every single term has to be multiplied by the LCD if it has a denominator, even if it doesn't have a denominator that's cancelable. Now, we can also solve inequalities and graph its solution set. Remember, an inequality has a range of numbers that can solve the inequality or make the inequality true. But the process for solving an inequality is the same as solving for an equation, except for a couple things, and that's what we're going to look at. So, we have solve negative 2 times x minus 1 plus 18 is greater than 3x plus 7, and graph the solution set. Pretend this is an equation. What do? You clear your parentheses first. So we multiply negative 2 through the parentheses, we get negative 2x plus 2. I'm going to write the rest of it here. Plus 18 is greater than 3x plus 7. All right, I'm going to combine my like terms. 2 plus 18. All right, and we get negative 2x plus 20 is greater than 3x plus 7. All right, remember the rule is get the x's on one side, numbers on the other. When you're doing inequalities, it's better to have the x's on the left-hand side for readability. So subtract the 3x. You get negative 5x plus 20 is greater than 7. Now move the 20 to the other side, so we have to subtract 20 on both sides. Negative 5x is greater than 7 minus 20 is negative 13. Divide by negative 5. All right, now that should set off alarm bells in your head. Do you remember from Algebra 1? When you divide by negative 5, when you're doing an inequality, what happens to the inequality symbol? Remember, it's going to flip. It goes the opposite way. And watch your signs. This works out to be x. Negative 13 divided by negative 5 is 2.6. So don't forget to flip if you divide by a negative. So your solution set is x is less than 2.6. That means that any x that is less than 2.6 will work in this inequality. It'll make it true. This side will equal or will be greater than this side if you plug in 2.6. Now, it says graph the solution set. When you graph a solution set, you put it on a number line. So here's my number line, and we put our critical point of 2.6 on your number line. Here's 2.6. Okay, now, is 2.6 included in this inequality? This says x is less than 2.6. If I plug 2.6 in here, is this inequality going to be true? No, it's not. So, since x cannot equal 2.6, I have to put a circle around 2.6. And if it's less than 2.6, my arrow has to go like that. So x is less than 2.6. Any value that I choose in this area will make this inequality true. So let's keep reviewing. If we have solve for x, we have this inequality, or excuse me, equation, x over x minus 3 is equal to x plus 4 over x minus 1. How do we solve it? Well, these are two fractions set equal to each other technically, so why don't we just cross multiply? Well, x times x minus 1 is equal to x minus 3 times x plus 4. Now, I wrote it like this purposely because we have to remember how we multiply these things. Now, x times x minus 1 is just distribute. X squared minus x. However, how do we multiply x minus 3 times x plus 4? Do you remember? It's FOIL. So we have to do x times x is x squared. X times 4 is 4x. Negative 3 times x is negative 3x. And negative 3 times 4 is negative 12. All right, now if we combine our terms, x squared minus x is equal to x squared plus x minus 12. Now, we want to get everything to one side, but look and notice here, x squareds are on both sides. When we subtract this one, we end up with negative x is equal to x minus 12. It actually cancels out. So let's go through and finish. Subtract the x. Negative 2x is equal to negative 12. Divide by negative 2. And x is equal to 6. And we've solved that. So if we plug 6 into this equation, both sides will equal the same value. All right, now it doesn't matter if you have numbers or if you have variables, the process is still the same. When you're working on this, you want to make sure that you're solving for the correct variable. This says solve for x. So we have to get x equals something with a, b, and c on the other side. So we have to undo what's been done. So there's a couple ways that we could do this. I'd get rid of that a first. Let's get rid of the a. Okay, if I want to get rid of the a, I'd multiply by the least common denominator, which is going to be a. So I'm going to multiply this side by a, and then I'm going to multiply this side by a. All right, what happens, you end up with a's canceling here, and you get x. And then a times b is ab is equal to ac. Now, all you have to do to solve for x is move the ab over. This is plus ab, so we minus ab. So we end up with x is equal to ac minus ab. Now, is that the only way to do it? No. If you wanted to move the b first, you could, and then you'd have to multiply both sides by a, and you can do that. That's perfectly fine. Now, there is also another thing, another step to this if you wish. Notice here that this is AC minus AB. Couldn't we factor out the A by reverse distributive and end up with C minus B? That's fine. Either of these answers would be acceptable to me. You can either go farther if you want to. Okay, last one. Solve for x. A times x minus b is equal to c minus dx. Rule, doesn't matter what variables or numbers you have in the problem, the rule is still the same. You want to get the x on the same side by itself. So, first thing you need to do, get rid of the parentheses and distribute. Watch your numbers. A times x is ax. A times minus b is minus ab equals c minus dx. Now, we need to get the x's on the same side. I have ax here, I have dx here. I'm going to put the x's on the left-hand side. So I'm going to move this minus dx, I'm going to plus dx. Now, I can't add ax and dx together and combine them into a single number, so I'm just going to write it as ax plus dx minus ab is equal to c. Now, I want everything on this side to have an x in it. Well, ab doesn't have an x in it, so it has to go to the other side. So we have to plus ab. Ax plus dx is equal to c plus ab. Now, problem. How am I going to combine ax and dx together? Well, I can't, really, because they have a different coefficient. The value's different. However, they both have a common factor of x in it. So, couldn't I say x times a plus d by reversing the distributive law? So, x times a plus d is equal to c plus ab. Now, to solve for x, well, isn't this being multiplied by a plus d? So, to undo that, we just divide. So, x is going to equal c plus ab over a plus d. And we have solved for x. Solve for x means x is equal to something with a, b, and c in it, and d also. So this should have been a quick review for you. This is all stuff that we did in Algebra 1. These skills are what you are expected to know when you come into geometry so that you can apply them in geometric problems. Have a good day.